Welcome to the last video for Chapter 4. So this is video part 3, and it's the last video where I'm going over the content for Chapter 4. As I mentioned in part 2 of this chapter, I didn't really want to go kind of definition by definition or area by area because I don't think that is going to add to your ability to learn this information. So my goal here was just to kind of give you a bit of a pop quiz, just to get you kind of considering the types of questions I might ask related to the brain. And some of these are kind of more application, where you get to kind of take the information you learned in the textbook and think through it from a more applied standpoint. So let's take the first question. So this structure interacts with the pituitary gland to control hormone release related to maintaining homeostasis. So I think homeostasis is probably the kind of trigger word that hopefully got you thinking of the hypothalamus, because the hypothalamus helps us regulate behavior related to the drives, including fighting, fleeing, feeding, and reproduction. Okay, next question. This structure helps you to evaluate incoming sensory information to determine whether you should approach it or withdraw from it. If you stimulate it, you might expect someone to act aggressive or irritable. If you damage it, you might expect someone to lose their fear response. This is the amygdala, because as you learned reading your textbook, the amygdala is very much involved in emotions, especially fear. And so to kind of bring some of these topics to life, what I'm going to do is show you some videos. I'll show you, I think it's 2 videos actually as part of this PowerPoint. The other videos I'm going to have to point you to a YouTube link because it's copyrighted, which means that it doesn't allow me to play the audio in this video. But for this amygdala example, what I'm going to do is I'm going to show you an example from research using rats, and so that's pretty common in the field of psychology. We end up using a lot of non-human animals to kind of simulate some of the experiences of being human. So fear is kind of a common thing between rats and humans, and so to kind of better understand or learn where fear is housed in the brain, what they did with these rats was they lesioned their amygdala, and so essentially they used surgery to take the amygdala offline. There's all sorts of ethics that come up when you're doing animal research. So I do want to kind of pause and kind of acknowledge that I know that this might be difficult for some of you to watch. I am an animal lover, and I have a hard time watching videos where I think an animal is being hurt. So I do want to say that I know this looks like this rat's being harmed, but he's actually not. So what you're looking at here, the 2 blue things, that's a robot with arms. And so these arms are going to close. And what you're going to see is that the rat is not afraid of them. And in fact, goes right between the arms and gets kind of knocked around a little bit. He does not get hurt. But again, I know it can kind of look upsetting. So again, what you'll see is the rat enters the screen. He does kind of get startled at first just because it surprises him. He didn't know what to expect. But even now that he knows those arms are going to move towards him, he has no fear. And so that is what can happen when there is dysfunction in the amygdala. And again, kind of highlights how the amygdala is related to the fear response. And so that does translate from rats to humans. So the next question is, what is the job of the corpus callosum? I know you read a lot in your textbook about like split brain patients, and so I think those particular examples really nicely highlight that the corpus callosum, has the role of passing information from the left to the right hemispheres of the brain. And so this is another one of the questions where I have a video to kind of highlight it. I couldn't show it as part of this PowerPoint because it is copyrighted. So what I'm going to ask you to do is go to Canvas, open the PowerPoint file, and if you click on this slide in the notes, there's a YouTube link, and it will take you straight to the YouTube channel, and you can watch that video with actual audio. And so it just shows an example of a split brain patient that really helped us learn more about how the corpus callosum helps the 2 halves of the brain communicate. And so it would be good for the time quiz to understand kind of the roles of the right versus the left hemisphere in recognizing faces and, naming, who you're looking at and being able to point at the face that's being referred to. So that was the example that was given in your textbook. So make sure you take a look at that. Okay, the next question. This network of neurons starts in the brainstem and projects to the upper cerebrum to arouse the cortex. If you lesion to this, you wouldn't be able to maintain cortical arousal to process information, and thus wouldn't be alert or conscious. And so I hope you realize that this is the reticular activating system. And again, as it kind of is very nicely described in your textbook, it essentially controls arousal. And so, when we talk about kind of the stimulation of the cortex to maintain arousal, we're talking about the reticular activating system. Okay, the next question. This structure contains a number of nuclei to help to control things related to sleeping and dreaming. And so that is the pons, which is essentially a grouping of neurons that do a lot of different things related to sleep and dreaming. The next one, when you drink alcohol, the structure can be affected, and the result is that you will begin to struggle to coordinate your balance and movement. And so that is the cerebellum, because the cerebellum is what is going to help us maintain balance. It's going to help us coordinate movements. And so when you consume alcohol, that area of your brain is impaired. And so then you're going to struggle to maintain your balance. So this is another one that I can show you the clip as part of the class just because there is no audio. And so again, I know seeing animals can really bring up a lot of emotions in people. So I do want to say this cat is very healthy. He leads a happy life. He's very high functioning. But what you're going to see is that he has a condition that impacts his cerebellum, which means that he has issues with his balance. Okay, so again, he is fine, he's safe, he's happy, but he does have some issues walking. And so here you can see the cat really has difficulty with coordinated movements with all four paws. He has a hard time maintaining his balance. In fact, he falls over when he tries to eat, but he is able to eat. He, again, he purrs. His only real issue is with, again, a medical condition that causes some dysfunction in his cerebellum, which I think really nicely highlights how it coordinates balance and movement. All right, this brings us to the last question. So all sensory information except for what goes through the thalamus before being sent to the appropriate sensory cortex? And the answer is smell. So again, I have a video. This is another one I wasn't able to embed into the PowerPoint because there's audio that's important to kind of understanding the story. So I'm going to ask you to do is go into YouTube. Honestly, you can just go to Google and Google thalamus twins. And any YouTube video that comes up about the story of those twins or any you kind of like written stories, any of that's fine. It's a fascinating story about twins that were born conjoined, and so they're actually conjoined at the thalamus, in addition to probably some other areas of their brain, and so they can actually experience each other's senses. Because again, that's kind of the relay location in the brain. And so because all the sensory information goes to the thalamus, if they're conjoined at the thalamus, that means that they're going to kind of have joint sensory information, which I just think is so fascinating. And again, so I think all these different examples, the rats, the cat, the twins, all of these really highlight the ways that we learn about the areas of the brain by kind of noticing what maybe is unique about the person or the animal, and then backtracking to determine what's different about their brains, and then that helps us better understand how all brains work. So really cool cases. Please make sure you look at the videos and kind of refer to the stories that I point you to, because I do think it kind of brings this information to life in a way your textbook just doesn't. Okay, so this last little bit, I just want to kind of highlight, that there is flexibility and resilience in our brain that I don't think we really truly appreciated just a few years ago. So I think many of us kind of believe this myth that once our brain is developed, maybe in like puberty, for example, that then our brain just kind of exists the way that it is, or maybe even begins to die off. But in actuality, we know that the brain has the ability to change and adapt throughout life, even later into life. And so, for example, it means that if someone has a traumatic brain injury, the brain might actually reorganize or grow new neural connections to try to compensate for what was lost. And so we refer to this as plasticity. So here are these little like squiggly lines. These are neurons. And so you can see that from, birth to 3 months, 6 months to 15 months, we see rapid growth in neuron connections. And they, the connections become more complex as the baby is learning and being reinforced and kind of taught to do particular things. Those connections are then strengthened, and that continues throughout young life as well. That we I don't know about you, but like I learned Spanish in middle school and then never really used that language, and so I don't know any Spanish anymore. Whereas if I had continued to use that language, that would be a skill I would still have. So essentially my brain pruned out those neural connections because I wasn't using them. And so we know that connections that are consistently activated, consistently used, they're going to be strengthened, they're going to become more complex, and then the neural connections that maybe aren't being activated are going to essentially die off and not remain any longer. So again, this is just to kind of show that the brain really does have the ability to kind of change and adapt in response to life in a way that I think early on the field didn't truly understand. So that brings me to the end of chapter 4. Again, I know I kind of glossed over some of the more complex sections of the brain, because I do think that that's kind of an individual learning experience for each of you to maybe make flashcards, or to kind of maybe create your own diagrams to learn and kind of associate the different areas with the different skills. But I am happy to go through anything that you need help with. If you have questions, please reach out to me. And that's the end of chapter 4. So I hope everyone's doing okay. This is kind of a turning point in the semester, I think, when people are starting to maybe realize where they're struggling, or in what particular classes maybe they're having more difficulties. So this would be a good time, if you're starting to get worried about this class, to check in with me, perhaps during office hours. So hope you have a good week, and I look forward to hearing from anyone who needs more assistance.